Today we're going to take a look at integers. We talked about integers last class period. When we talked about them last class period, they were sort of in a diagram. And in the diagram, I had these dot, dot, dots, and then I had a series of numbers, and I had dot, dot on the other end of them. And one of the ways that I described them is that they were whole numbers that were either positive or negative. So our whole numbers are the ones that we count with, 1, 2, 3, 4. And the number 0 included in that. And integers include the negatives of those numbers as well. Integers occur all over the place. Sometimes people get frustrated as our number system expands as they go through school, and they're like, well, negative numbers, that's not reality. There's no such thing as a negative number kind of thing like in real life. The actual answer to that is that there's lots of things that are negatives in real life. And so I'm going to give you a couple of examples of real life things that are negatives. So one is in temperature. So it can be 50 degrees Fahrenheit or negative 50 degrees Fahrenheit. And for those of us in Oklahoma, you're like, there's really a negative 50 degrees Fahrenheit? Yes, there really is. When we were living in Ohio, we were a part of a ministry called Angel Food. It's not associated with Angel Tree, but Angel Food. And my husband would go as a pastor of that church and go pick up the angel food. And it's like a food pantry kind of a thing. And it was so cold. It was in the negative 40s to negative 50s in the wintertime in Ohio, picking up food from those freezers. That's how cold it was. So there's definitely negative temperatures. Another one that we see used in a different context is that you can be 1,000 feet above sea level or 1,000 feet below. And we interpret that as a negative 1,000 feet when we are 1,000 feet below sea level. Now, I mean, obviously you could be in the ocean, like in the ocean and be 1,000 feet below sea level, but you can also be below sea level and simply be in valleys that are nearby sea level areas. Like that can happen. They just are dry or they don't fill up with water because of the way the landscape is. We talked last time about graphing on a number line, and the examples that you were working with were all with positive numbers and decimals and things like that for graphing on a number line. But we also have number line graphs that would include the negative values. So just like last time when I said on a number line, smaller values are to the left and bigger values are to the right, well, it's still true, but the reference point is with the reference point of 0. So as we're referencing the number 0, we would move positive to the right, because those are bigger than the negative values to the left. So for example, if we wanted to plot the number 5, we would be to the right of 0. And if you wanted to do negative 5, you would be moving 5 to the left of 0. So all the numbers are negative on the left, they're positive on the right. And the further you get away from 0, the bigger the value of the number, ignoring the sign, gets. So negative 5 is roughly where I plotted it, but negative 1 is here. It's not 5 and 1. It's negative 5 and negative 1. Another application of negative numbers is in terms of values of money, right? So a negative 5 would indicate that you owe, or you were negative in your bank account. Don't do that. $5. That would be worse. It would be more, like it would be a bigger value negative, right? Further away from 0 than the value negative 1 if you only owed somebody $1 or you were only $1 negative in your bank account, okay? So the first thing, example that you're going to do for me today real quick on your piece of paper, and you can put all the hash marks on there for me as well, is you're going to plot 10 and negative 7 on the same plot. Again, I would mark the number 0 as a starting place and then go right and left from there. It's a terrible 0. Let's try again. So take a second to do that, and we'll make sure we're all on the same page. Okay, so if you've plotted 10, you should have plotted it to the right of 0 like this. And if you've plotted the -7, it should have been to the left of 0 like this. And I need to put my dots on there, so let me do that too. So there's my -7, and here's my +10. So label it, please, but also put a dot, all right? Both of those things. If you want to label hash marks in between, you can. It didn't hurt anything. In general, I wouldn't label every single one of them. It's a little tedious, and it becomes really tight and kind of messy maybe the more you put in there in the places. But if you want to label some of the values in between, you could do that. Some basic ideas. One of them I've already mentioned. With your number line, 9 is less than 10. But -9 is greater than -10. And I know that feels sort of funny if you're just looking at the 9 and the 10. But negative values mean something different. They mean that we owe something. In general, what we're thinking about in terms of a number line is how far away are we from 0? Which one's further away from 0, right? So while 9 is less than 10, 9 is closer to 0 than 10. -9 is actually bigger than -10 because it's also closer to 0 than -10. Okay, so you're thinking in terms of distances. All right, this example looks very similar to the one we did yesterday with the inequality symbols. We can use 2 different symbols in any of the blanks to fill them in properly because we're given both the less than sign and the less than or equal to sign, the greater than sign and the greater than or equal to sign. And in your homework, sometimes they give you 4 options. They could do that, or they could give you just 2 of the options, or maybe one of their options says, the equal to symbol or something like that as a third option. So what symbol would we put between -3 and -10? Which of those numbers, let me ask it this way, between -3 and -10, which of those numbers is bigger? -3, it's closer to 0, right? It's further to the right. That's actually maybe a better way of saying it. It's further to the right on the number line, so it's bigger. -3 is bigger, and our symbols want to open in the direction of the larger value. So -3 is greater than -10. Or, what else could you put in that blank? Yeah, you could put the greater than or equal to symbol, and it would be equally correct. All right, which of these numbers is bigger, 2 or -5? 2. On this one, it kind of feels funny, right? It looks 2 and 5, but the 2 is positive, right? I'd much rather have $2 than owe someone 5. Yeah? Yeah, that's a bigger value, net worth kind of thing. So yeah, 2 is greater than -5. All right, so adding and subtracting with negative numbers. There's 3 different sort of categories of things that can happen when you add and subtract. You could have the same sign, right? They're both positive or they're both negative, the 2 values. So you're somehow using things that are combining the same sign. So when you have the same signs, you add the values and keep the sign. Man, that's huge. I think my pen's a little too big for today. Let's try that again. I just need to zoom in further. I don't know. All right, so we'll do some examples of these in a minute. Different signs. So let's say one of the signs is positive and the other sign is negative. That's what different signs would mean, right? Then what you do is you subtract. Larger number, that's not a hashtag, that's a number sign, just so you know. Larger number minus the smaller number. And you use the sign of the larger. Again, we'll do an example. And the last thing that can possibly happen is that sometimes you have subtracting of a negative. My 6th grade son keeps saying minusing and plussing instead of adding and subtracting. But you're subtracting a negative, right? So when you subtract a negative, you always end up with a positive. And as an example of what that looks like, just as a reference point, is something like this. If you had 7 minus negative 5, that's equivalent to saying 7 plus 5. Okay, so subtracting a negative, or as my son would say, minusing a negative, that's addition. It's actually addition. Okay, so you have 4 examples here. So what I'd like for you to do, if you're comfortable anyway, is to do your 4 examples. Do your best with them. If you make a mistake, it's okay. And see if you can turn to somebody near you and just check and see if you got the same answers. All right? Just see, do they match? So you don't need to get anywhere close to somebody really to do that. Just see if your numbers match as you get the answer. So do the 4 yourself first, and then check in with someone. Okay, so problem number 1 is an example of ones that have the same sign. So when we have the same sign, what you should have thought to do is to take each of the numbers, ignore all the positives and negatives because the signs are the same, right? Negative, negative, signs are the same. And you add them together. So what's 6 plus 7? 13. And then whatever the sign is, you keep the sign. And the sign is negative. So this is negative 13. Number 2 is an example of one that's actually different signs, right? It's negative 6 and it's positive 7. So what we literally do is we subtract them. We do 7 because it's the bigger of the 2 numbers, minus 6. So what is 7 minus 6? 1. And then we keep the sign of whichever number was bigger. So which was the bigger number? 7. Was it positive or negative? Positive. So this is 1. It's positive 1. The next 2 have different signs as well. 15 is negative, 13 is positive. So 15 is larger, so 15 minus 13 would be 2. And we needed the sign of the larger one, so what is the larger number? It's negative, so we would have a negative. So it's because the sign of the larger on the negative is 15. On the 15 is negative. All right, and then the last one is an example of that last case where we have subtraction with a negative in sign, negative in addition. And so we have those 2 negatives. This actually means that it's the same thing as addition, right? Minus a negative or subtracting a negative. So 6 plus 2 is 8. Okay. All that stuff I know you've seen before. Do you remember it? Good. Good, good. All right, so let's keep going then. So we did addition and subtraction basically with signed numbers, positives and negatives. Now we're going to do multiplication and division. So multiplication and division is kind of the same in the sense that you use the numbers as they are, right? Just like in the last one, you use the numbers as they are, kind of ignoring the sign, and then whether I add or subtract depended on the signs that were associated with those individual numbers. Well, with multiplication and division, you multiply and divide as you would have if they were all positive numbers. The only difference at the end is whether or not the answer is positive or negative. So if the signs are both positive, you get a positive. That's old school stuff. Like that's what you were doing when you first learned to multiply and divide and had no idea negative numbers existed at all. If the signs are different, a positive and then a negative, that's negative. Yeah. So if the signs are different, and if the signs are both negative, we actually are kind of like over here in case number 3, subtracting a negative. Yeah, it's positive. So when we multiply, it's much like subtracting a negative, it becomes positive as well. 2 positives is positive and 2 negatives is positive. So if you think about sort of a way to categorize this, you can think of it this way as well, is that if you have the same signs, it's positive. And if you have different signs, right, they don't match, it's negative. Okay, so we're going to do the same thing again. You're going to take a look at the next 6 examples. And you're going to do your best to do the multiplication and to choose the proper sign. I don't have any examples well, I do actually in the next set. I wrote this all down as though it's multiplication. It's true for division as well. So I wrote multiplication of positive times a positive, but it's also true for division. If you have a positive divided by a positive, it's also positive. So all the same stuff works for division. So it doesn't matter whether you're multiplying or dividing, positives and negatives, they have the same properties. I didn't write that separately, but it is a true statement. And you'll need it on your next slide. So you have 6 examples. So take a look at those 6, write down what you believe to be the correct answer, and check in with somebody nearby you and see if you do, in fact, have the same things. Okay, so check in real quick with somebody next to you. Just make sure your answers are matching, or if they're not, decide maybe the error that might have been made. Okay, what did you guys get on number 1? Negative 18. Awesome. Different signs, so they're negative. How about number 2? 32. Yep, 32. Positive because they're both negative, right? Same signs. Same signs gives us positive. 3 is division, but it doesn't really matter in the terms of signs. What's negative 8, right? It's negative because they're different signs. How about number 4? Numbers 4 is 4. They're both the same sign, so we get a positive. Interestingly enough, 5 and 6 were not directly things I addressed, but it's still true that you can look at how many signs you have that are the same or they're different. So on number 5, did you get positive or negative? Negative. And the reason that you should have gotten negative is because there's 1 negative. It's an even number of negatives involved. What's 6 times 2 times 3? 36. Great. Awesome. On the last one, how many negatives are there? 4. So if you take 2 negatives and they make a positive and another 2 negatives and they make a positive, now you really have a positive number, exactly. So we have an even number of negatives on the last one making it positive. And what value did you get overall? 120. Yeah, it's 120. Any questions on those? Nope. Hi. What's going on? I don't know. All right. Next topic, we're going to take a look at distance. The distance between two values is the larger value minus the smaller value. It's always the larger value minus the smaller value. So if you think about it like on a number line, it's the number that's on the right-hand side, furthest to the right, minus the number that's on the furthest to the left-hand side, if you're doing the distance between two numbers. So we'll draw that out here in a second. This one says the distance from 2 to 6. It'd be 4. So 6 is the larger of the two numbers. So this equivalently means that we're doing 6 minus 2. Right? And you guys said you're right. It's 4. So thinking about it from the perspective of a number line, here's 0. Here's 1, 2, 3, 4, 5, and 6. So if you take a look, visually speaking, right, how much space is there between those? 4. Now, do be careful. Sometimes we're sort of in this mindset of counting things. And so if you're thinking about counting here, you're counting spaces. You're not counting hash marks. I know there's 3 hash marks in between it, but there's 4 spaces. So imagine somebody having to jump. You'd have to jump 1, 2, 3, 4 times if you were playing leapfrog or something like that to get from the 6 back to the 2. So the distance between them is always 6 minus 2. Another way to think about distance is to simply think about it in terms of this sort of accounting argument, because distances are always positive. Right? If I talk to you about how far I live away from OBU, I'm never going to tell you it's a negative number. That doesn't make sense in terms of the context of the word distance, right? So whether I drive from OBU to OBU to my house or my house back to OBU, I'm always talking about the distance in a positive sense. There's no direction to it in terms of the word distance. So another way that you can actually think about it is simply subtracting the numbers in any order you wish and just knowing that the answer is going to be positive when you're done. So I'd like for you to find now the distance between -6 and 2. What is the bigger of those two numbers? 2 is bigger. So if I want to write this out in terms of a mathematical sentence, I would actually be writing 2 minus the smaller number, which is -6. And what happens when I do minus a negative? It's positive, right? So I actually get 2 plus 6, which is 8. So that's one way to think about it in terms of numerical notation. You could also think about it in terms of a number line, right? Here's -6. Here's 0, and here's 2. They're not 4 apart. They're 8 apart. 6 numbers on the negative side, distance-wise, and 2 numbers on the positive side, distance-wise. That's 8 units apart. So if you think about it, if the numbers are small enough to think about it, and you want to think about it that way too, they're 8 apart. So it's a distance of 8. So if you're visual, maybe you really like that number line sort of picture as to why that's working. If you like sort of rules and structure on top of your numbers themselves, the first one. I don't care which of those methods you use to describe why the answer is 8, but like I think it was Christina. Were you the one? No, Cooper. You were the one who asked me earlier. Madison. Who's, oh my goodness. Cooper, right? Black mask. Is that you? Are you Cooper? Who's Cooper? You're Cooper. I'm missing a person. Are you Haley?
Yeah.
Awesome. I was at Haley. Once I get this in a picture that actually makes sense with the classroom, I'll be doing better. Haley had asked on the question about our last assignment, like what do you need to show, kind of. I mean, that wasn't exactly your words, but that was the gist of what you were asking. You don't have to show both of these methods. I don't care which one you show. It doesn't matter to me in the slightest. They're both legit ways of thinking about why the answer is 8. You can just pick whichever one you like or makes the most sense to you, and you can use that one. Does that make sense? Yeah? Okay. So, reminder of what we're doing now. This is it. We're done. Normally, what I would have you do is either to go to work with yourself by yourself or work in pairs, and you would be working on 1.2. We don't have 1.2 necessarily enough printed out, but you will when you come on Wednesday, right? You're going to have 1.3 printed, or you're going to have your tablet on which you're doing your homework, either way. And using the information that you sent me, and I'm sorry, who came in late? What's your name? Sarai. Okay. And Sarai, what I asked everybody to do, and I'll ask you to do as well, is to send me an email that says whether you would prefer to work alone or whether you would prefer to work in pairs when we're doing work in class, so that I make sure and am helpful to everyone in what their preference is on that. And I also really do need, the 4 of you who needed help, raise your hands on getting their stuff uploaded into Canvas. Who needed help getting stuff uploaded into Canvas? I thought there was 4. Is there only 3? Okay, everybody look. If you're sitting near one of these people, what kind of phones do you guys have? Raise your hand if you have an iPhone, those 3 of you. You do? Let's see. Is it Maddie? Do you have an iPhone or do you have an Android? iPhone. And Jasmine, do you have an iPhone? Or an Android? Okay, well, Divine's helping her. Okay, if somebody would help Maddie and if somebody would help Brianna to help them get that uploaded, I would really appreciate it. And then everyone else, you're welcome to head on out. I will see you tomorrow with your 1.2 either uploaded or you can bring it to class and upload it after we do questions. Either way, okay? Have a great day.